Okay, so here is a titanium 700 short action going in for receiver blueprinting. Basically, we snug up the fixture here. Nice thing about this setup, we don't have to go too crazy on the screw torque. It's just got to be snug, it's just got to hold it. And from here, go to our program and cycle start. It's going to run through a probing routine here, actually a few of them. Right now we're setting the Z axis based off the lug abutment of the receiver. Then we're dropping down. We're hitting some points off the receiver ring. Now we're taking the inverse. Careful to avoid hitting the lower guard screw, because that would skew our readings. And we'll roll it 180. And now we'll catch points on the bottom side. It's going to go just below the trigger web into the rear bridge portion where we've got qualified diameter. Even though it's not a whole hole, we're using a modified probing routine here so we can catch as many points as we can. Now it's stored all those points. And from here, we're going to put our little plug gauge in so that we know where the bottom of the thread is. And get it started here. My fumbling hands can make it work. There we go. Roll into the bottom, index it back counterclockwise to 0, close the door, cycle start, roll back to 0, fire the probe back up, mash into the top of it, picks it up, rolls it back, and now take it apart. Now it's going to come back in and reestablish Z, because if we have an angular deflection, that meant one lug is possibly taller than the other because it was at an angle. So now we're going back and resetting the Z, and we're resetting the XY0. First operation was just to get the receiver plumb with the spindle bore. So it's going to bang through those same points, only on this side now because we know we're straight. Now it's putting it away and getting ready to go to work. First tool is a 1/2-inch end mill. And with one tool we're going to come in and buzz the face. Just taking a whisker pass, 2.5 thou. Now we're going to plunge, and one operation we're going to whisker pass the lug abutments and qualify the internal bore diameter. So we're done there. That'll put that tool away, and we can look in there if we want to. And it pauses long enough for us to look. Make sure everything got machined that it's supposed to. It all looks good. So now we hit cycle start again. Sometimes on receivers you'll get to where one side will ghost a little bit, and you got to go back and drop it down just a skosh to get everything cleaned up. So there's the through spindle coolant. Now we're milling the threads, basically just winding like a spiral staircase. So it's climbing out. Almost there. And we'll shut down here in a second. I always get paranoid and I let the tool run a pitch, usually a pitch and a half to 2 pitches above the part, just in case I ever have an offset issue. The last thing I want to do is wrap it out of the hole with it still engaged in a thread. We're not trying to win a race here. Now we're going to come in and chamfer it. And this is titanium, so it makes a little noise, but there's no chatter. Now the chamfer will look big because we have not come in and done the Higby cut, the truncated lead thread. That's next, and it'll bring everything into perspective here. We're all done with that. Now we've got a nice truncated lead thread. That just means that we don't have a real thin razor blade thread lead on it. And now we're going to drill for our pin recoil lug. Drill cycle's pretty slow. Small diameter drills in titanium, you got to be a little conservative with it. Otherwise you burn stuff up, and the worst thing you can do is stuff a 3/32 carbide drill inside a piece of titanium, because it's a nightmare to try to machine it back out. So finally we got a little stub carbide 094-5 drill, just a skosh over 3/32 so that our recoil lug pins will slide in and out nice and easy. And we see a nice chip forming. It's not birds nesting around the drill. It's actually able to break it off. And we're almost there. And we go on to the next one. This particular receiver has already got 840 scope base holes, so all we're doing is the front end work on it. So this right here will be the last operation. There we go. And that little noise at the end there was as soon as it comes out of the hole, I turn the spindle off and reverse it. Spin it up to 10,000 RPM, and that way if there's any chips on the drill, it'll clean them off. There she is, right in the machine. And before we go and remove it, we'll get our plug gauge. Definitely tell it's tie. It gauges, but it is sticky, which is typically what it does. So the go gauge, for it to be appropriate, needs to go all the way into the hole, not rattle around like a marble in a can. And the way I was always taught, on a no-go, you get up to 3 rotations. If it's over 3, the thread's no good, it's junk. And right there we engaged. We got maybe a 1/16 of a turn. So we're going to call that good. Now New machines. You're not allowed to do a damn thing unless you got the door shut. Kind of lame. Now it's going through the shutdown cycle, and we are done. Grab our wrench again. Average cycle time on a short action like this, with the paperwork, everything, you're looking at about 7 minutes. And there's some little things I can do to tune the program up to be a little more efficient, but right now we're just vetting the basic code. We're not, like I said, we're not trying to win races with this. Just pop the collet loose. And it's ready to come out. And that is right off the machine. So here's the twin sisters. And the nice thing is it's a repeatable process. We spent all weekend vetting this. But anyway, thanks for watching.